Hi, I'm Professor Vogler, and today we're going to be talking about simplifying radical expressions. And you have a note page that we'll be using as we go through our discussion. So, what exactly is a radical expression? Well, a radical expression is something where you have a radical sign, sometimes called a root sign. You have something underneath that sign we'll call our expression. And then there's a little number out there, sometimes called the index. And if we don't have a number, we take it to be the square root. So suppose I wrote something like this. The square root of 48 x to the fifth y cubed. Well, that's a radical expression. And today what we're going to do is figure out how we would simplify something like this. But before we get to that, I want to go back and I want to talk a little bit about some of the basics. And the basics begin with our perfect squares and their particular roots. Now, on your handout, you have a list of all of the perfect squares, and you have a list of the square roots of those perfect squares. So, for example, if we take a look at 3 times 3 is 3 squared, or 9. So the square root of 9 is 3. When we discuss a square root, what we're saying is, what's the number that when we multiply it by itself, it gives us back the original perfect square? Same thing with the square root of 16, 25, and so on. But what if you have a square root of something that's not a perfect square? Like, what about the square root of 2? Or what about the square root of 3? Well, now we can go into our calculator and we can punch in those numbers, and we find that the square root of 2 is going to be 1.4142. It's going to keep on going. We can figure out that the square root of 3 is 1.732 just by putting it into the calculator. But we don't always want to have a decimal for a square root. What if we wanted to take a look at something like the square root of 27? Well, again, if we put it into our calculator, the square root of 27 is going to be 5.196, and it'll keep on going. But you know, sometimes, just like with fractions, we want to have something in its original form, but we want to have it simplified. So, for example, if you had the fraction 9/12, you could turn that into a decimal, 0.75. But what if you really wanted to just leave it as a fraction? Well, we'd want to simplify it. We'd want to make it 3/4. And that's our simplified form of a fraction. In the same way, with a radical, we have a simplified form. Now, our simplified form for the square root of 27 goes back to those perfect squares. And if we take a look at the square root of 27, we want to look first at the factors of 27. 1 and 27, 3 and 9. Well, to simplify this, we can rewrite the square root of 27 as the square root of 9 times the square root of 3 by taking the square root of the factors. Well, we've already identified that the square root of 9, that's a perfect square, is 3. And then we don't know what a simplified form of the square root of 3 is, so this is our final answer. The simplified form of the square root of 27 is 3 times the square root of 3. And what we're doing there is taking out all of those perfect squares. Well, let's do another one. What if we wanted to look at the square root of 72? And this is the next one that you have on your handout. The square root of 72, well, 72 has a lot of factors. There's 1 in 72, there's 2 in 36, there's 3 in 24, there's 4 in 18, 6 in 12, 8 and 9. Now, any of those pairs of factors would work if we wanted to simplify that radical expression. But I'm going to go ahead and start with 8 and 9. So we could write the square root of 72 as the square root of 9 times the square root of 8. And again, we know that that square root of 9 is a 3. And some people would simply stop and they'd say, well, the radical is simplified at 3 times the square root of 8. But it's not, because the factors of 8, we can still write this as the square root of 4 times the square root of 2. Don't forget, we still have the 3 out there. Well, the square root of 4 is a perfect square. This is 3 times 2 times the square root of 2. So our final answer here would be 6 times the square root of 2. And that's our simplified radical form for 72. Now, what if you don't always have numbers? Because remember, eventually we want to be able to simplify something like this. Well, if you don't always have numbers, you need to remember one thing. If you have a variable and it's squared, the square root of that something squared is nothing more than the something, in this case, x. And that's because this is a perfect square. So let's say we wanted to simplify, the square root of x cubed. Well, we could write that as the square root of x squared times the square root of x. But the square root of x squared, that's a perfect square, it's x. And we leave our square root of x in this part of our term. So the simplified version here would be x times the square root of x. If we wanted to go a little bit further and do, say, the square root of x to the 7th, well, we can break that up. This is the square root of x squared times the square root of x to the 5th, because those exponents add to your 7. This is an x, but we can still simplify this as the square root of x squared times the square root of x cubed. And so, if we keep on simplifying, we know that the square root of x squared is this x, and we've already determined that this is x times the square root of x. So our simplified version here is x cubed square root of x. Now, you don't want to have to break it up like that every single time that you have a variable. And so we have a shortcut. And here's our shortcut. If we take the square root of x to the 7th, and as you can see on your handout, what we say is take the exponent underneath your radical, which in this case is 7, divide it by the index, which in this case is 2. 2 goes into 7 3 times with a remainder of 1. And so to simplify this, what we do is we write x on the outside with the number that divides in evenly, and we write x on the inside with our remainder, in this case 1. So we get x cubed square root of x. And that's our final answer. So, last but not least, let's look at this square root of 48 x to the 5th y cubed. In order to do this, we're going to simplify it by breaking up our variables and our number. This becomes the square root of 48 times the square root of x to the 5th times the square root of y cubed. And whenever we simplify 48, this is the square root of 16 times the square root of 3. And we know that's a perfect square. We can simplify this by breaking it up with our little shortcut. This goes in twice with a remainder of 1. And so this becomes x squared square root of 1. And the same way, this becomes y square root of y. And when we put it all together, we get 4x squared y square root of 3. This isn't a 1, this is x to the first, x, y. And that's my final answer. Next time we'll look at what happens if we have something other than a square root. What if this index is a 3 or a 4 or a 5? I look forward to talking with you again.